How's it going, guys? Today we're gonna talk about discontinuity. So yesterday I made a video about continuity at a point. Well, today we're gonna talk about discontinuity at a point. And for this video, I'm gonna give only one example because for the next video, so not tomorrow, the next day, I'm gonna make a bunch of examples. So it's gonna be like a video only for examples, but I want to touch all the topics before I get into them because they're going to be useful for them. So today we're going to talk about removable discontinuity. Tomorrow, then we're going to talk about essential discontinuity. So let's start with the definition of what removable discontinuity looks like. It says, let f be a function such that the limit when x approaches c from the right is equal to the limit when x approaches c from the left, which is equal to the limit when x approaches c of f of x, which is equal to L. And f of c, this is the important part, is not equal to L. Then we say that c is a removable discontinuity, okay? And in mathematics, in general, names have meaning. So the point of calling it removable discontinuity is because you're removing just one point of the continuous function. You're making it discontinuous by removing one point. That's why it's called removable discontinuity. Okay. Now a graphical representation might look something like this. So notice that this function f has a limit L, right? Because as x is approaching from the left of c, my function is approaching to L from the left. And when x is approaching from the right of c, my function is also approaching to L. But notice that f of c is this point, okay? Therefore, f of c is not equal to L. That's how a graphical representation of a removable discontinuity might look like. Now I'm going to give an example. Usually, this type of examples are what? Piecewise functions. You probably have guessed that already. So for this function, we're asked if there's a removable discontinuity at 2. Okay? So how do I know that, or how do I find that? Well, you use the definition. You first find if the limit exists. If it exists, and the value that the limit gives you is not equal to the value at the point, then it's a removable discontinuity. So let's do that. So the limit when x approaches 2 from the left of of g of x is what? Well, if I'm approaching from the left of 2, x is less than 2. So it has to be x squared plus 4. Okay? Now, if we plug in, remember, 2, we get 2 squared plus 4, which is 4 plus 4, which is 8. Now, the limit from the right of 2, if it's to the right, it means that x is greater than 2. So it'll be x cubed. If we plug in 2, we get 2 cubed, which is 8. Okay? So notice that the limit exists. And is equal to 8. Well, what is the value at 2? Well, the value at 2, notice that the equality is at 5. So g of 2 is equal to 5. Notice that these two guys are not equal. Therefore, this example is an example of a removable discontinuity at 2. Okay? And that's how you prove it. Now, we can also graph it. I'm going to graph this function by hand. Hopefully, it looks nice. So 1, 2, 3, 4, 5, 6, 7, 8. Let's do 9. Then 1, 2, 3. Okay. So the first one is x squared plus 4. This is a transformation up 4 units up, 4x squared. So 1, 2, 3, 4. Okay. Then it says that for x less than 2, I'm going to use that function. So this is 2. So everything that is less than 2, I'm going to use x squared plus 4. So to the left of x squared plus, oh man, let's try that again. Much better. And then to the right. But at 2, so the limit when x approaches 2 from the left, it lands at 8. But at 2, it's a different value. Now, at 2, we have 5. So 1, 2, 3, 4, 5. So at 2, we have this point. Then it says for x greater than 2 is x cubed. Okay? So how does x cubed look like? So it's like a S shape, right? But it's for values only greater than 2. So it's gonna land something like this. Well, maybe not that curved. Something like that. Okay? So notice that the limit is still 8 because as x approaches 2 from the left and from the right, we have that value 8. But at the point 2 is 5. Okay? So that's the example that I wanted to give. That's what the point discontinuity, removable discontinuity looks like. Okay. Our next video for tomorrow is going to be essential discontinuities, which is a little broader than this one. So it's going to be, this next video is going to be longer. So I hope you enjoyed it. Please like the video, subscribe to Motivao, share it with your friends, go to my website, go to Facebook, Twitter, whatever you want, okay? Have a great day.